My name is Garrett Benish. I'm the Director of Development at BIOFORCE Tech, and I've been developing our material that we call our carbon for market. So what we have here is a biochar that's made from biosolids, which gives it unique characteristics, and it's pound for pound carbon negative. So every pound that gets used somewhere, you're fixing a pound of CO2 into the built environment, into products, into the world around us. So we really have a two-sided business model here. So we're stopping the sewage sludge from going to landfill or getting applied on land where contaminants proliferate. And then we're taking this new material that we can produce from it and using it in industry and using it in markets as well to change business as usual on the other end. So what we have here is what I call our car mile jar. I call it that because the actual amount of carbon that's fixed in this material is the same that would be emitted from driving a car for 1 mile. So you can see how these small amounts of material can expand to make a huge impact. So once the material gets produced, it drops down here and climbs its way up this screw conveyor as it cools down and then goes into these bags where it gets shipped off to industry for many different uses. And one of the main uses that we use our carbon for is in concrete. So what I'm holding here is a 6,000 PSI mix, very, very strong concrete mix that has the same structural properties of a standard mix, except that it's 60% reduced in carbon footprint because of the material that we make that's going into it. So we can replace aggregates in a way that allows us to store carbon in the built environment for good, for over 1,000 years. Another use is replacing a extremely common pigment known as carbon black. So the black that you see in this shoe is made with our carbon instead of that material, as well as this screen printing ink that's made by Virus Inks. If you look around you, whatever you're doing while you're watching this documentary, I can assure you, whether it's your TV, your computer keyboard, your car tires, your black t-shirt, all of that is dyed with carbon black. It's made by burning fossil fuel byproducts and collecting the ash. So when we replace that material in pigmentation applications like footwear, polymers, all the same ones, we can stop that material from being produced, which really takes a big hit to the fossil fuel industry to shift business as usual. We're in a position where it's all hands on deck, and there's so many different parts of our system that needs rewiring. So being able to take something that rewires a waste system on the front end from a municipal standpoint, fixes carbon in the middle, and then rewires an industrial end on the application side really allows us to do as much systematic change as possible. If you look at any graph showing the path to net zero emissions, you'll see that the biggest chunk that needs to change is what we're doing now. And so changing that business as usual, removing carbon emitting technologies from our industrial system is the biggest impact that we can have, as well as making these carbon negative materials.
So my name is Dario Prezezzi. I'm the co-founder and CEO at BIOFORCE Tech Corporation. I founded this company about 11 years ago with the goal of diverging organic waste and changing the way we think about waste. So society today, what we're doing, it uses much more resources that we can take, and if we are producing at least 16 to 20 times emissions that what we can afford to live sustainably on this planet. And so what we looked at is this problems of waste that a lot of people were not really focusing on, but it actually contributes to climate change and emissions quite a bit. And so we took it as engineers, we took it as an engineering problem and start focusing on how do we solve it completely, how do we make the most sustainable possible process that we think of. And that's what we come up with. So drying it efficiently, transforming it into a product, making sure that every single step that we do is checked and we know exactly what we're emitting, so that at least for this specific waste that we're focusing on, we think it's the most sustainable and something that can go in the future. So if we're talking about biosolids and sewage sludge, what we're doing differently is we're actually transforming the waste into a product. Where before, other technologies were trying to reduce only maybe the volume of waste so that you can pay less per ton. But still, at the end, you got waste and you need to put in landfill. What we're doing very differently is we're transforming it into a product by also sequestering carbon. The carbon benefit in a nutshell is the carbon that is contained inside waste, it's now transformed and locked into a final product that without oxygen in our process, it locks it in for thousands of years. So every ton of product that we produce, it's 1 ton of sequestered carbon. And then if we look at all the avoided carbon, then we're talking a 10 to 1. So 10 tons of carbon avoided and sequestered into a single ton of product that we generate. What is special about biochar is, first of all, that locks in carbon. And second of all, it's clear from especially what we are treating. So we're treating impactful feedstock that has a lot of PFAS and other contaminants. What's special about this biochar at the end is like it's completely free from these contaminants. We have demonstrated with the EPA that we destroy also PFAS, one of the hardest forever chemical that exists out there. And so what is special about it is like now you have something that can be used, like made of like pure carbon and other elements that can be used in many processes. Yeah, so producing biochar means taking a feedstock that it's an organic matter, and then running it through a process which it's completely deprived of oxygen. So it's an oxygen-free environment where we heat up at high temperatures, and what happens is the biomass actually evaporates, so part of it evaporates into a separate gas that we can be used to generate renewable energy, but then some of the carbon then get locked in, where it's very different from incineration, where you're putting oxygen and burning off all the potential. Yeah, so to scale this technology, it's quite easy in the sense that we made it modular so that it can be installed in every possible city out there, every possible wastewater treatment plant by adding modules. And it's added at the end of their processes. So it doesn't change too much the way they do business now. They just need to add one piece of equipment, which makes them from a waste generating process into a product generating process. And it's easy to scale because again, like it's very modular. It can be installed outside. It can be installed simply on a flat cement pad, and makes it easy to deploy. Yeah, I mean, climate change is an enormous problem, but we see it as changing business as usual, right? So if we are focusing on a small part, but it has a big impact, which is the organic waste generating methane. So what we do is for industries like we need many industries or many startups like trying to tackle every single problem. They're enormously challenging problems, and so we focus strictly on the impact of feedstocks, and we believe this technology that can take care of this part at least. Yeah, I mean, what I can say is like trying to solve this giant problem seems to be crazy challenging, maybe too much sometimes. So we think about, let's stop doing everything, so maybe we solve it. But the way we address it is we see the problem and we know that we need to change the way we're doing things. So we cannot only add more things to do, we definitely need to change the way we're doing things. But doing things, that means creating industry and creating new companies that can work on these problems. We just need to shift the way we look at things from be wasteful and be growing only, where we could be fixing stuff by growing anyway and like making industry and creating jobs and so on. All right, so our system, what it does, it's automatically diverge sewage sludge that before was going into trucks into these bell conveyors. And the bell conveyors bring it into our system that it's made of 2 machineries. The first one is called the biodryer. And the biodryer, what it does, it actually dries this very wet waste into a very dry waste by using bacteria instead of using natural gas. All this process is done automatically. And then once they're done, they unload dry solids into a very long conveyor that brings the dry solids into the second step of the process. The second step of the process is where the magic happens, and that's where we transform what it was waste into a final product that it's biochar. Also, what it does, it generates renewable energy. So this renewable energy is used to run the entire system, which now is self-sustained. And so what you get at the end is 10 tons of waste, or like 10 times get reduced into one only ton of a product. So from a waste producing facility, we now have a product producing facility that makes this final carbon negative carbon capturing product. So this right here, it's the end product. It's now completely odorless, free of contaminants, free of PFAS, and can be used directly into concrete or products. As you can see, it's fully black and easy to manage. So really like truly a product and not a waste anymore.
I'm Dylan Hayworth, and I'm an intern with BioForce Tech. I come from the Colorado School of Mines, and my role is working in the research and development area of BioForce Tech. And we're working with an experimental pyrolysis unit to test different biomass feedstocks and produce them into biochar so that we can try and later test them at an industrial scale. I've been doing research on biochar as like a way to sequester carbon in practical applications such as cement and concrete for a while. And so to finally be a part of the actual commercial side of things instead of just research at school has been kind of exciting. It's so much fun to see that biochar actually has a place in this world and that we're able to change with the changes that Earth has been having. Well, it definitely can seem hopeless from many perspectives, but even if we were at a point of no return, it would be foolish not to try. I mean, we're going to be living in this world and our children are going to be living in this world, and I hope to be doing that for as long as possible.